Static methods technically work with FastMCP decorators, but the official docs warn against decorating them directly for an important reason. We'll demonstrate exactly why the decorator won't return a callable static method when applied this way, show the simple two-step registration pattern that avoids this issue, and explain how this maintains proper method behavior while still exposing the function to FastMCP's tool system.
From FastMCP, import FastMCP. MCP equals FastMCP. Class myClass. @MCP, tool. @staticmethod. Def utility, x, y. Return x plus y.
This demonstrates how static methods interact with FastMCP decorators, where the combination technically works, but breaks the static method contract. The decorator converts the method to a regular function during processing, which means the resulting object is no longer a callable static method. The key distinction here is that while Python allows this transformation, it violates the expected behavior of static methods in class hierarchies. The mechanism works because @staticmethod first converts the method to a function, which the FastMCP decorator can then process normally. However, this sequence means the decorated version loses its static method properties, returning a plain function instead of a method descriptor. The framework sees a valid callable, but the original class design intent is compromised, as the method can no longer be called through normal static method invocation paths. This matters because it highlights the tension between framework integration and Python's method types. While the code executes without errors, it creates subtle maintenance issues where static methods behave inconsistently depending on whether they're accessed through the class or directly. The recommended pattern, defining the static method normally and registering it explicitly with MCP, tool, class, utility, preserves both the method's original behavior and its framework integration, avoiding these hidden contract violations. Let's break it down line by line.
From FastMCP, import FastMCP.
Static methods work with FastMCP decorators, but this pattern isn't recommended. The @MCP tool decorator won't return a callable static method, breaking the method's expected behavior. For proper registration, define the static method first, then explicitly register it with MCP, tool, class, utility. This maintains the static method contract while enabling tool exposure.
MCP equals FastMCP.
Static methods work with FastMCP decorators, but this approach is not recommended. The decorator chain converts the static method into a regular function, breaking the static method contract. For proper registration, define the static method first, then explicitly register it with MCP, tool, class, utility.
Class myClass.
Static methods work with FastMCP decorators, but this pattern isn't recommended. The decorator chain converts the static method into a regular function, breaking the static method contract. For proper registration, define the static method first, then explicitly register it with MCP, tool, class, utility. This maintains clean callable properties while keeping the function in your class namespace.
@MCP, tool. @staticmethod. Def utility, x, y.
Static methods work with FastMCP decorators, but this decorator order isn't recommended. The @MCP tool decorator won't return a callable static method, breaking the static method contract. For proper registration, define the static method first, then explicitly register it with MCP, tool, myClass, utility.
Return x plus y.
Static methods work with FastMCP decorators, but this decorator order is not recommended. The @MCP tool decorator converts the static method into a regular function, breaking the static method contract. For proper registration, define the static method first, then explicitly register it with MCP, tool, class, utility. Static method registration. FastMCP processes static methods by converting them to regular functions through the decorator chain, but this breaks the static method contract and isn't the recommended approach. The decorator will not return a callable static method, making the decorated version behave differently than expected in class contexts. For reliable results, define static methods normally and register them explicitly using MCP, tool, class, utility, after class definition.
The method that sheds its class becomes a function that answers to no one.